In this video, I will talk about graphs of the trigonometric functions, and in particular, changes in period and how that relates to the equation for the graph. So we will focus on y equals a sine bx and y equals a cosine bx. So our focus will be in this area here, where we have the angle being x. The output is the value of y that we are graphing as a point. So we want to remember still what y equals sine x and y equals cosine x look like before any changes have been made to them. The values of y repeat every 2 pi radians or 360 degrees. So I've already introduced y equals sine x, and let's put that up here. It will look like, and this does repeat, so it goes from 0 and down and back, okay, and that's our 360 degrees, or 2 pi is that far. So halfway is 180, and the maximum is at 90, the minimum is at 270. Each of those go to 1 and minus 1. Okay, so we have these 5 key points, the zeros. In sine x, we have 3 of them between 0 and 360, and we have a maximum and a minimum. I'm going to focus on those key points when I am graphing the new functions with changes in period. This period, the length of time for one wavelength is 360 degrees. That is one period right here, which equals 360 degrees. Okay, and for cosine x, all right, let's write that one down. We've got y equals cosine x. We'll graph it also. It starts on a maximum at 1. So we'll do this in blue. It ends on a maximum after 360 degrees. Halfway between those two at 180, it has a minimum. And halfway between the max and min, we have zeros. All right, so it looks like this. All right, we will be focusing on those key points as we make changes to the period of the function. This b value in the equation, when it is a 1, the period is 360. So when we change the b to other values, either less than 1 or greater than 1, this is when the period becomes changed. So determine the period of a function. Before we get started graphing it, we can use these two equations. If we're working in degrees, the period is equal to 360 degrees divided by b, whatever the b value is. If we are working in radians, then the period is 2 pi divided by b. We will still use the 5 key values to sketch the trigonometric function to include its period. So in our first example, we're going to graph y equals sine 2x. Now, we have to remember what y equals sine x looks like when the b value is a 1, and now this b value is equal to 2. Okay? Graphing y equals sine 2x. Let's first calculate the period. The period is equal to, I'm just peeking to see, we're in degrees. So let's do it in degrees. 360 degrees divided by the b value, which is 2. So the period is equal to 180 degrees. Now what does that mean? The period is the length of time for one wavelength. So we will see one full wavelength within 180 degrees. That means in my 180 degrees, I need to see all my 5 key points, right? So if you look at this graph that I have here, the blue line is the original y equals sine x, where we have a 0 at 0, 0. The first maximum is at 90. The second 0 is at 180. The first minimum is at 270. And the last 0 is at 360. For y equals sine 2x, what happens is we need to see one period within 180 degrees. And you see that. We will see the first 0, the first maximum, the second 0, the first minimum, and the third 0. Now let me take a look at how I would graph that using the 5 key points. So let's just draw ourselves a little bit of a place to graph, okay? I can take some of that out of there. We've got our y, we've got our x-axis. We are graphing y equals sine 2x. And I know that my y equals sine x does that, okay? I've calculated the period, and it is 180 degrees. So I should show one full wavelength. So from 0 to 180 degrees, I need to get my one full wavelength. Now remember, I think in the previous lesson, I talked about the 4 quadrants being exhibited here. So what I generally do is I take the period and I divide it by 4. So that's 180 degrees divided by 4. We'll end up with 45 degrees, which means I need to see those 45, I need to see the 4 quadrants. So halfway of 180 is 90, halfway there is 45, and halfway between that will be 135. Now let's put our 5 key points on. We know that the first, at 0, 0, we have a 0. We also know that at the end we have a 0. I'm referring to those two right there and there. And we also know that in the center we have a 0. In between those zeros, we know that we have a maximum. And in between the second and third 0, we know that we have a minimum. And so, there's our graph. And it would repeat with the same going in either direction, okay? So when I'm stressing about the 5 key points, that's what I mean. Use those 5 key points. You can use this fact, take your period, divide it by 4, and you are including the 4 quadrants, and then you place your graph in that spacing. So to make a general statement about what this 2 did, what the 2 did is it gave us 2 full wavelengths in 180, because we can see we have one there and a second one there. So that 2 tells us how many waves we will get in 180, therefore the period is half of that. Now let's take that knowledge and look at graphing another one with a different b value. I'm going to graph y equals sine 0.5x. This tells us there are half as many cycles in 360, not twice as many like before. So you will see, and this has been done in radians, but we can convert to degrees if we want. Our 180 is here. There's our 360. And so that blue line is y equals sine x without any change, and the light blue line is y equals 0.5x, sine 0.5x. Let's calculate the period. This one happens to be in, the graph is in radians, but I can change it to degrees, and I'll even plot the degrees on there. That would be, so that's 360, this would be 720, okay? So 360 divided by 0.5, which is 720. If I take my 720 and divide by 4, we get 180, right? That means to show my graph, I would mark a 720 on here. Halfway to that is 360. Halfway to that is 180. And that's 540. And there are my places for my 5 key points. We know that we have zeros at 0, 0, and we have a 0 at the end. We also have a 0 in the center. And we have a maximum halfway between the first 2 zeros, and we have a minimum halfway between the second and third 0. So the graph will look like this. Now, as you can see, these basically all look the same. What has changed? The labeling of the x-axis and, of course, the y if I had any change in amplitude. So label your axes. You cannot just show something that looks like that. All right, that's not going to work. It's got to be labeled. It's got to be relatively even spacing and so on. So you can see this relates here. If I look back at my original graph here for y equals sine 0.5x, it starts at 0, 0, it goes up and it decreases, and the second 0 is at 360, and that happened right here. We show the rest, show one full wavelength always when you graph, and it ends at 720. Okay, now, here's another example that involves sketching two things that have changed now. Remember, the general equation was y equals a cos bx, right? We've already talked about what a does. We've talked now about what b does. So we have two things that we need to change as we graph the cosine function. I'm going to, up here in the corner, keep my graph of y equals cosine x handy. My 5 key points are what I need to graph when I change it. I want to remember that my amplitude has changed. It's not 1 now, it will be 0.5 or half. And the period has changed. So the period is equal to 360 divided by 4, which is 90. If I want to get my 5 key points and my 4 quadrants within the 90, I will take my 90 and divide by 4 again. Now it's not 4 because of that 4, it's 4 because of the 4 quadrants. Which will get me at 22.5 for each marking. Okay, Let's go ahead and see if we can do this now. We'll draw ourselves a place to graph. And move that a little bit there. Okay, let's label y, x. Good. We are going to get, well, let's go to, we know the period is 90, so I got to go to at least 90 here. Here is where I take my 90, divide by 4. I'm going to do my 4 quadrants between 0 and 90. So halfway, that's 45, and halfway, 22.5, and halfway there is 67.5. All right. I want to put in the correct amplitude. So I'm going to go up to 0.5 or 1/2, and I will go down to minus 1/2. Let's plot our zeros in red. We know that for y equals cosine x, we have zeros on the second and the fourth points, so they're going to be here and here. We start on a maximum, travel through that, go to a minimum, and back up on a maximum. So the graph goes levels and steep at 0 and levels off, levels, steep at 0 and levels off. Now if you would like to continue that on the other side of 0, get the same spacing, minus 22.5, minus 45, minus 67.5, and we'll squeeze that in here, minus 90. We'll continue with the same pattern. It's going to drop there. It will go to a minimum here. The next max is at the end, just so I don't have to change my color and my zeros in between. So let's follow that pattern. And so on, okay? That's where I'm saying we've got the 4 quadrants. 1, 2, 3, 4. Cosine is positive in quadrants 1 and 4, negative in quadrants 2 and 3, according to the cast rule, and that is matching. Okay? So have a look at that. Okay, and lastly, I'll just get you to practice stating the amplitude and period of the following functions. Pause the video and work them out, and then when you resume, I will go through the answers. All right, so amplitude is the absolute value of A. The y equals A cos EX, and y equals A sine BX are our general formulas, right? So the absolute value of -5, which is 5 for the amplitude. Now for period in this case, since we have a pi involved, that implies radians. So the period is equal to 2 pi over the b value, which is 4 pi, and this equals 1/2. So 1/2 a radian is the period. 0.5 radians. For the second one down here, the amplitude is equal to the absolute value of A again, which is the absolute value of 2/3, which is 2/3. Now this one, we can't tell whether it's in radians or degrees. Let's work it out in degrees. The period is equal to 360 divided by B, which is 8 in this case. 360 divided by 8 is 45 degrees. Okay, so that's it. I recommend keeping in mind y equals sine x and y equals cosine x before any changes have been made. Thinking about the 5 key points of each one. Divide the period into the 4 quadrants as you graph and label your axes. That's it for now.